In this video, I'll be helping you with the ALEKS problem type called using the unit circle to understand the odd and even identities for sine and cosine. And this example has three parts, A, B, and C. Starting with A, we're asked to sketch the angle pi-thirds radians here in the first part. And by now you may recall that these tick marks represent multiples of pi halves, and these represent multiples of pi sixths, with this first being 1 pi sixths and the second one being 2 pi sixths, which is the same as pi thirds. So this would be the sketch of pi thirds. The second example, negative pi thirds, is just going in the opposite direction, so swinging down. This would be our negative pi thirds. And now that we've sketched pi thirds and negative pi thirds on the unit circle, we can move down to our questions here. Part B has us giving the exact values, first for the cosine of pi thirds and then the cosine of negative pi thirds. Looking back at our graph, first for pi thirds, the coordinates here at the terminal location, since this is a special value, we know that the cosine has moved from 1, which is the square root of 4 over 2, to the square root of 3 over 2, the square root of 2 over 2, and then the square root of 1 over 2, which is just 1/2. That's the cosine. That's all I need for this question. But I'll go ahead and indicate that the sine, the y value here, moving in the opposite direction would be the square root of 3 over 2. So this is 1/2. And for the second one, the cosine of negative pi thirds, our cosine is again moving from 1 over 0, getting smaller. The next tick would be the square root of 3 over 2, the square root of 2 over 2, and then the coordinates here are the square root of 1 over 2, which is 1/2. And again, I'll put the sine in here. The sine is moving down from 0, so this would be our negative square root of 3 over 2. But the cosine value is just the 1/2, the same as it was for the cosine of pi thirds, which is going to let us answer here part C, because we can see that the cosine of negative theta, here our theta being pi thirds, is the same as the cosine of theta. So we get the same value whether we took a positive theta or a negative theta. This would be an even function. So part A here is true. And as a reminder, in case you have a different example, even plugging in a negative has no impact. F of x is the same as f of negative x. And odd functions, we would have the opposite value when we plug in negative x as what we get when we plug in x.